Welcome, very good evening. Thank you very much. Due to technical problem, I have to restart again. Today is day 42, Water Chemistry Live with Jakir. Thank you very much for connecting with me with a long time. Due to the disturbance, I like to restart, and I just want to start another just for a minute a song to set everything perfect again, and then I will come on the topics today. Thank you and apologize. Thank you very much. Thank you. Welcome everybody, and apologize for the inconvenience due to the technical problem. So here continuously we are on discussing live chemistry. So today is day 42. We have discussed starting from the water chemistry. We stand on discussion on the biocide and organism control. Today we like to look on more on the biocide and its different functional things. We are discussing like internal water treatment. We classified it as a BCS, if you all remember: biological problem, corrosion problem, and scaling problem. We have discussed the detail on scaling, corrosion. We are standing on the biological and biofouling problem, and detail we discuss what are the fact figures or the region because of this kind of problem. So we discuss algae, bacteria, fungi, legionella. And now we are discussing how we can control very much. Thank you very much those who are connecting and who will listen later. Also you can ask question and comments so that we can discuss accordingly some later also. So during the discussion yesterday class and day before yesterday on day 40 and 41 we discussed that to control microorganism, we have to do different strategical approach. We have to control on the environmental factors. We have to design, we have to think for physical cleaning also, because if the things is so badly foul, sometimes the other strategy can apply, can work. So we have to go for physical cleaning. It might go for physical cleaning, and definitely as a proactive problem solution provider, we have to do some chemical controls. All this control is a synergic. If we want to control our organism, we have to follow all this synergic and strategic control mechanism or methodology. So if we see the physical cleaning requirement, if we fail to control our organism at lag phase, then we have to go for the physical cleaning. Otherwise, in the stationary phase, chemical might not work perfectly. So we have discussed this preliminary and primary qualifying criteria yesterday. That primary qualification criteria for any biocide, it should be very broad spectrum, it should be flexible enough, the optimum dosing should be there, it should be economic, it should be wide range of functionality. So many things we have discussed. And as per chemistry or chemical, we discussed this is a broad two category, two type of chemical broadly we are using, that is a biocide and biostat. And we declassified biocides as the killer who directly killed organism, and biostat who inhibit the growth of the organism. And if you see the biocide, there are especially two kind of biocide, that we call oxidizing and non-oxidizing biocide, and all together there is a lot of trade name is available in the market that we call biocide, microbiocide and microbicide, algicide or algicide, slimicide, and many. This is a trade name people call, all are the put in the same category. If we saw the disadvantage, there are severe disadvantages for using oxidizing biocide only. So you have to be very focused and very specialized to control environment like pH, like sunlight, aeration, then the corrosion aspect, the demand of different because of the different elements in the system. We already discussed this kind of things yesterday. I just wrap up. And definitely the effect of the pH, that is always having the problem. If pH high and less, the chlorine and bromine, that is always the bromine is better than the chlorine. So these are the some functionality that is required to understand the activity, and that based on that we have to control, we have to select the chemistry. So again, broadly the non-oxidizing biocide is two categorized. We discussed yesterday. I just wrap up here again. Thank you, Fazle Rafi. The biocide is a kind of metabolic poison. Another is surface active biocide. We call them metabolic poison biocide and surface acting biocide. So what is the difference? We just discussed yesterday a bit. The metabolism poison or metabolic poison kind of biocide, they actually destroy the cytoplasm, and they just work as an inner part of a bacterial cell. So they just destroy the cytoplasm, and that's why they call the metabolic poison, because the structure remain okay. They penetrate inside the bacterial cell and destroy the inside part of the bacteria. And surface active biocide, and the surface active biocides are those biocides those work outer surface of the bacterial cell. The cell, they may be dissolved, they may be the cell, they can do many things, they may be burned, they may be put the charge, and they destroy the outer structure, and bacteria got killed. So these are the things that we discussed yesterday. And today we discuss what are the chemistry, what are the different kind of chemistry group those work as a biocide. There is 100, there is a couple, there is several chemistry that work as a biocide. We can't tell the name one by one, but we can give the generic name. We can discuss the functional active group that are the used as a non-oxidizing biocide. This is the left side. Is if you see the table, including the metabolic and surface active poison, there are a lot of chemistry or chemical group that can be used for biological control. You can see quaternary ammonia compound or quaternary different other compound, polymery quartz compound, organotin compound, organosulfur compound. There are a lot of chlorinated phenolic compound in this derivative. You all know the organic chemistry is a very big number of chemistry. So depending on the actual practical requirement and the patent, and many big companies who develop, do research and depending on the requirement of the system, they design the chemistry, and that's why there is no unique individual ingredient product in the market that is as a basic chemistry. So all are the group of the functional group of the chemistry that can be used as a microbiocide or biological problem. There are some chlorinated phenolic compound. There are many heavy metal salt type of compound that can be used for as a biocide, and there is a rosinamide salt type of chemistry and compound and functional and derivatives. There is a acrolein compound and its derivatives, the dibromoamide compound, and there is a different compound of this kind of group. I just mentioned the functional broad group. So organothiocyanide, dodecyl compound, and many more. I just pick out some very common functional group or common broad group. Those are 1 or 2 or 3, they blended, and depending on the demand, depending on the chemistry, they patented it and they develop a biocide, and that's why all the biocide come as a patented number. You will not find any independent compound or independent only the base chemistry. There is a very less chance of getting the good quality biocide. So if you see all the chemistry, all the chemical 1, 2, 3 or any kind of formulation can be. Thank you Palash, thank you Fazle Rafi. So all this combination, they produce a lot of biocide and it is available in the market, and we have to be very careful for selecting the product, and we will just discuss how we can select that. And depending on the function of the metabolic poison and surface active agent, we just try to show you some basic difference, and those are the factors to lead to choose. So as a lot of chemistry is available, if we want to choose any biocide, welcome Shakil Mahmood, Assalamu alaikum, thank you very much. So if we want to choose any biocide, what biocide we should choose for my system or for my cooling tower or my water body, then we have to understand all these things very carefully, and that's why we need to understand what is the surface active agent work and how they work. If you see the metabolic poison, the metabolic poison usually work as a slow acting poison. They take 1 to 6 hours to kill the bacteria, because they have to penetrate inside the bacteria cell, and then they have to slowly destroy the bacteria cell inside cytoplasm and other protein or nutrient or many things. So that's why they are the slow poison. They have to penetrate inside the cell structure, so it takes time. It can go up to 6 hours, 8 hours, even 12 hours to kill a bacteria. So all the metabolic poison actually need longer time. Rather, if you see the surface active agent, they need very low time. They are working very fast. They can work as within an hour, within 2 hours, or very less time, less than 4 hours. But for metabolic poison, it takes long time to kill the bacteria. So depending on my situation, my water condition, we have to choose which biocide I should use. And metabolic poison, they act more rapidly against the active cell. That means metabolic poison, they like to kill. Metabolic poison want to work as a live cell, the active cell, the cell that is growing fast. So that kind of cell, they work very effective. And if you see surface active agent, they are effective against algae also. They are also broad pH range, means they are a broad spectrum. And if you see the metabolic poison, the rapidly degradation by plants, sunlight, etc. So definitely sunlight has an effect. So sunlight, if you dose within sunlight or heavy sunlight, so you have to dose higher chemistry, higher chemical. And surface active agent is a less human toxic, but metabolic poison is a higher human toxic, because surface active work very fast on the surface, but they can flash away very fast. But metabolic poison, they stand water very long time, maybe 6 hours, 8 hours, 12 hours. So this is very human toxic, and basically their functionality is direct killing the bacteria metabolic part. So that's why they are more toxic. But still all the chemistry are toxic. This is just a comparison. Compared to surface active agent, metabolic poison type of biocide is more toxic, but both are actually toxic. As a toxicity comparison, metabolic is more than surface active agent. And if we want to choose a right biocide, we have to be consider many important factor, and that is basically expert work, and that is basically, and water expert only can select the right product for you. You also need to be understand why this product is selected, and if the technical people know this, they can also choose the right product for their system. So what are the things that actually, again, more understanding, you need to be understand types of the organism present in your system. Like if it is a cooling system, then you have to be assume, or you have to be have experience what are kind of the common organism might present in my system. It is the general like algae, fungi, bacteria, or in the bacteria what category bacteria might be more in my system. Can be sulfate reducing bacteria is there, can be iron bacteria there, can be sulfur bacteria there. If we can understand the very specific kind of bacteria will be more. We know every system there are different kind of bacteria ratio will be there. There is no unique bacteria, will be only the bacteria. So we have to be understand as per the system environment, site condition, available water chemistry, available source of the water. So depending that we have to be select, or have to be clearly get the idea which kind of bacteria will be the majority, or what are the 4, 5, 6 category of organism or bacteria might be in my system. If my system have sulfate reducing bacteria or more, or if my system have sulfur bacteria more, if my system have E. coli bacteria more, or if my system have bacteria less, algae problem is high, if my system have mold problem is high, or yeast problem is high. So that is the knowledge very important. Depending on the organism knowledge, or if I know what type of organism majority present in my system, then I can choose the right biocide, and I can kill and control the bacteria and organism very effective way. Then I can keep my system clean. So definitely if we don't understand the organism present in my system, we might be we might be use the wrong chemistry for the controlling, and definitely if we use wrong chemistry, you know the consequences, the failure of the microbiological control. And definitely we need to understand the type of cooling water system. Is it once through, is it recirculating cooling system, is it open recirculating, is it closed recirculating, is it contaminated with process, is it going to any fertilizer or any power or any food industry, what are the contamination might come in my system. So we have to be understand the type of the cooling water system. It is a metallic, non-metallic, it goes to SS, MS. So there are a lot of things we have to be understand. So definitely to select a better biocide, any kind of biocide, oxidizing or non-oxidizing, we must understand the type of cooling water system. And next one is operating history. Maybe some problem already they faces, and some issue is already faces of the industry. So if we don't know the history, what are the past history, or what are the area of nearby other plant facing the problem. And thank you Walaikum Assalam Shakil. It's okay, due to the technical problem my Facebook actually main account somehow locked, I can't access it, so I am also facing a lot of problem. So I tried to get it on JTZ display this account to work. So last 2 classes I am here, so you can have me here unless I recover my account. Thank you very much. It's okay. So we need to understand the operating history of the plant. We need to understand the problem of the plant. We need to understand the common issues of the plant. Depending on that, we have to select the product. So guys, if you have any question, you can ask me definitely right now, or also you can ask me later also, and I'm sure you can hear me clearly, you can see my screen clearly. So operating history give us the many interesting aspect to select the right product. And if we understand the operating history, the chance or effectiveness or chance of selecting right product, always the probability will be high. And if we don't know the history, we just select any product, it may be the by chance, it may work, it may not work. So we have to be very careful on that. And definitely nature of treatment of using corrosion and scale inhibitor also. because it's a synergy. The corrosion control, scale control and biological control, it's a synergy. If we don't understand, like if we want to use corrosion inhibitor from one company, scale inhibitor from another company, biocide from another company, if each of people don't understand what kind of corrosion inhibitor they are using, what kind of scale inhibitor they are using, what kind of biocide they are using, if they don't understand, so as a chemical it may interfere one another, and maybe corrosion inhibitor efficient the biocide, or maybe biocide maybe work against the corrosion inhibitor, maybe scale inhibitor functional destroy, scale inhibitor maybe cannot function because of the presence of the biocide are effective. So as a whole water treatment, or especially cooling water treatment, is a synergic treatment. We have to control all the corrosion problem, we have to treatment scaling problem, we have to treatment the biological problem. If we control one only very good, other two not good, then definitely we can't control actually any problem. So that's why there should be a continuous integration, there should be a synchronization, and there should be a compatibility that we discussed past also. Compatibility is very important factor for any this kind of treatment. Like my corrosion inhibitor, scale inhibitor and biocide should be compatible with one another. So it should not against one another, it should be complement for one another. So that's why we have to be understand the nature of treatment of corrosion inhibitor, means corrosion control, scale inhibitor, to select the right biocide also. And definitely we have to be understand physical and chemical characteristics of the water, the source of the water, the biological contamination of the water, the pH range of the water, the alkalinity of the water, the metal and other TOC, other total bacteria of the water. If we don't select the product considering the water physical and chemical characters, we might miss, we might not have the right product, we might fail to control the microorganism. You guys, you see the lot of specialized things have to be considered to select a right product. That's why most of the company, most of the cooling system fail to control the microorganism, and you see the algae is there, slime is there, so a lot of the failure case in our hand, in our understand. Thank you Bajit, thank you very much for connecting. So we have to be considered the physical and chemical characteristics of the water to select the right biocide for even oxidizing and non-oxidizing both. And definitely we have to be understand the environmental restriction. Like there are a lot of chemistry just discussed before. Heavy metal or different kind of heavy metal compound can use as a good biocide, but due to the environmental restriction, many of the good biocide is banned, because heavy metal now not allowed for any treatment. So some smart company in Bangladesh, they just carry this kind of chemistry as a low price, and they sell out without knowing of the customer. So this is also dangerous for the customer, dangerous for the customer environment, customer nearby community. So we have to be very careful, we have to be understand the product chemistry. Is the product is environmentally acceptable, is the product is biodegradable, eco-friendly, health friendly, human friendly, then only we can choose the biocide. Because all the chemistry is toxic, but the toxicity limit should be within the local environmental restriction limit, within the community standard, within the discharge limit. If the biocide is not environmental friendly and it is a restricted listed biocide, so usually we should not select this kind of biocide. And last not the least, it must be cost effective. There are a lot of biocide is very expensive, but dosing is very low. There are a lot of biocide very cheap, dosing is very high. So we have to be considered on the total cost, not only the unit cost, and we have to be considered the right selection, we have to be considered the technical part, and then definitely if technically matched, then definitely the cost should be effective. If technically matched, correct product, same product for the right product, then the cost comparison will help. Otherwise, if only we look for the cost effectiveness, if we don't consider the other all the factors, and here cost effectiveness is the last factor, but if we don't consider the other factors, only considering cost effectiveness, then my system will be there is a lot of chance to fail the system. So these are the some selection criteria. Those are very important for any system, any plant, to select the right biocide, even oxidizing and non-oxidizing. Guys, if you have any question, you can ask me. Another very important thing, we know the biocide kill the bacteria, and biocide work to kill the bacteria either on the bacteria surface or bacteria inside. But if it is not they not reach to the bacteria surface or not to the bacteria inside, they can't kill. It is just diluted with the water and they waste out with the blowdown. So every biocide, if we have to be it is functional, we have to keep the surface clean, we have to keep the bacteria surface clean. So that is why biodispersion is mandatory. Biodispersion clean the surface of the bacteria, keep the bacteria empty. If there is a suspended particle or other things is surrounded by the bacteria, slime is surrounded by the bacteria, enzyme is surrounded by the main bacteria structure, so biocide can contact with the bacteria. The biocide can penetrate or cannot destroy the structure or surface or cell of the bacteria. That's why for selecting biocide, there should be good biodispersion combination, either in a combination or in a separate. We have to get the biodispersion, and every biodispersion have special different kind of characteristics that we call penetrant property. Like they have a hydrophilic and hydrophobic property we discussed during the fouling. So the hydrophobic part is like to be hide themselves from the water, so they come to the surface, or they just hide themselves from the water, so they penetrate inside the bacteria cell and inside the suspended particle. So they make a hole. By the hole, biocide can reach to the bacteria surface. So biocide can only work when sufficient biodispersion efficiency is there. And some biocide also surfactant. The surfactant, they wet the surface of the slime, they wet and disperse the area where biocide can be hide, so biocide can penetrate inside. When the surface is wet, so biocide can penetrate inside the bacteria cell and they can kill it. So during selecting any biocide, beside the actual biocidal chemistry, biodispersion also need to be considered. And there are a lot of biodispersion chemistry like DMAD, DTA and APG. There are a lot of detailed biodispersion chemistry must be present in the biocide itself in a formulation, or it can be used as independently. So without biodispersion, biocide may fail or may not work. So guys, thank you. Today is now 11:08, so I like to close the call today. From tomorrow I like to discuss more here. And finally, depending on the many other factors, we have to select the chemistry and how we can dose it. This is also we like to discuss further more. So I like to stop here. If you have any questions so far, you can ask me. You can write and comment. And thank you very much for joining. I keep this video live on the JDJ Bachman the account. As a technical problem, I can't reach other account, and I will keep it on the sharing on YouTube channel, so you can have over there. I just request you, please go through all the video that we already missed, and you just remember this is now open knowledge, as you have to be take the knowledge to future ready, because now only the option we can learn our knowledge, we can learn, enhance our capacity to work better in next level when the things will be very common. So we'll discuss tomorrow again 10:30 p.m. from here, the biocide choice and how we can choose the biocide and how we can dose the biocide and what are the other factors we have to be considered to work with the biocide. So by the time, stay strong. Thank you and good night. See you tomorrow 10:30 p.m. on the same account, and you will get all the video on the Water TV channel on YouTube. You can watch over there also. Please do share with your friends and group where they can also enjoy and they need to have this knowledge. Thank you very much, and take care and bye bye. Assalamu alaikum and good night.